Okay, take two. So I think there's a few people here. If you're here, welcome. If you're watching the recording, welcome. So yeah, quick disclaimer. I have already solved this. And I have already solved it in Rust. However, the solution is really ugly, and I think that we can come up with a better solution that's more rusty. Either way, if you're interested in the code, it's all at git.light.dev/lightdev/advent of code. All my code's here. You can go to 2022, Rust, source, and day two. So this was my initial solution. It's pretty ugly. I'm wanting to come up with something cleaner, as well as just kind of walk through, I think, a more rusty-ish solution for the day two. Let me make sure I can see the Twitch chat. Beautiful. Okay, so let's go ahead and dive in. Here, just as more getting stuff out of the way, here on the right, this is just my scaffolding, right? So I have a chunk of code here that will just pull in the input text file that I've already downloaded and saved to my disk. And then I'm just printing the results from part one, which takes the input as an argument, which is just a string slice, and similarly for part two. Additionally, I have some tests down here. One of the nice things about all of the advent of code problems is, if we scroll, they usually provide like a test input and the answers. So it's really easy to set up some unit tests, and I really like to start with that. But before, well, sometimes I usually do plug that in first, so I'll start with that. So I usually ignore all of this and find the test input and the test solutions. So here we can see I've already solved this, but we're going to ignore this for now. But I'm going to grab this test input and just dump that in here and clean it up here. So there's my test input. And I can see here the answer for the test input for part one is 15. And so I'm just going to go and modify my test so that does that. So the other thing I'm going to do is I'm just going to set up a little watcher. So I use watch exec for this, and this is basically like, hey, if I edit any .rs files in this directory or any of its subdirectories recursively, I'm going to do tmux clear here. Then I'm going to run this command, and so this will just clear this terminal, this tmux pane, and then it will run the tests for this day two binary, and then it will actually run the day two binary. So I usually kick that off and like to make sure that my tests are passing. So here you can see one test is failing. I'll change this one to pass. So we can see test part two is passing right here. So that's this guy, because it's just returning 0 right now. So yeah, and then we know that this part one should result in 15. Right now it's resulting in 0. So that's I really like the test, and it sort of highlights what things were. One thing that the tests don't do that I really want to figure out is, like, if I have output somewhere in my code. So you can see there, I'm editing files, and as I save them, it's just rerunning those tests. But as I'm changing those files, oh, hey, look, there's the output. Never mind. Rust is so good. Never mind. Okay, so back to the problem. Okay, so I'm going to read through this and sort of decompose the problem, hopefully in a rusty sort of way. Yeah, we'll approach a solution, and hopefully we can get done in less than an hour when I have my first work meeting. Okay, so the elves begin to set up camp on the beach, and to decide whose tent gets to be closest to the snack storage, very important. A giant rock, paper, scissors tournament is already in progress. Rock, paper, scissors is a game between two players. Each game contains many rounds. In each round, the players each simultaneously choose one of rock, paper, or scissors using a hand shape. How am I running tests in watch mode? Great question. I'm not. What I'm doing is I'm using, this is watch exec, and I'll just throw that up there so you can copy it. It's also in the repo for this, sort of what I'm using. But watch exec is just like a file watcher, and then it will run whatever command you like. And so then I'm just running my tests and then running my actual binary through cargo that way. So I'm not running tests in watch mode with Cargo. I'm just watching the files myself using this tool and then running the tests. Great question. Okay, so rock, paper, scissors. Yeah, everyone knows how rock, paper, scissors. A winner for that round is selected. Rock defeats scissors. Scissors defeats paper. Paper defeats rock. If both players choose the same shape, the round instead ends in a draw. Appreciative of your help yesterday, one elf gives you an encrypted strategy guide, which is your puzzle input, that they say will be sure to help you win. The first column is what your opponent is going to play. A for rock, B for paper, and C for scissors. The second column, suddenly the elf is called away to help with someone's tent. Okay. Foreshadowing. Spoilers. The second column, you reason, must be what you should play in response. X for rock, Y for paper, and Z for scissors. Winning every time would be suspicious, so the responses have been carefully chosen. Ah, clever. The winner of the whole tournament is the player with the highest score. Your total score is the sum of your scores for each round. The score for a single round is the score for the shape you selected, 1 for rock, 2 for paper, and 3 for scissors, plus the score for the outcome of the round, 0 if you lost, 3 if the round was a draw, and 6 if you won. Since you can't be sure if the elf is trying to help you or trick you, you should calculate the score you would get if you were following the strategy guide. For example, suppose you were given the following strategy guide. A, which that denotes that my opponent plays rock. I would play Y, which is paper, which would mean I win. And they would throw B, which is paper. And in response, I would throw X, which is rock. So I lose that one. And then they throw C, which is scissors. So I throw Z, which is also scissors. That's a draw. So this strategy guide predicts and recommends the following. In the first round, your opponent will choose rock, A, and you should choose paper, Y. This ends in a win for you with a score of 8. 2 because you chose paper, plus 6 because you won. In the second round, your opponent will choose paper, B, and you should choose rock, X. This ends in a loss for you with a score of 1. In the third round is a draw with both players choosing scissors, giving you a score of 3 plus 3 equals 6. 3 for choosing scissors, 3 for a draw. In this example, if you were to follow the strategy guide, you would get a total score of 15. 8 plus 1 plus 6. Those are the 3 rounds. What would your total score be if everything goes exactly according to your strategy guide? My answer was 12535. Okay, so this is a fun little problem. One thing I usually like to do is I like to go look at the actual input. So for me, that's going to be this file. So yeah, it's just a whole bunch of lines of text where there's a 3-character line string on each line. 3-character line? Long. 3-character long string on each line, where the first character is either A, B, or C, and then there's a space, and then the third character is X, Y, or Z, and then there's the new line after that. Okay, so this is pretty straightforward. One thing that I think we can do is we can set up in enum for our rock, paper, and scissors. I don't know how you're supposed to say enum. What do you even call this? Choice. So there's rock, there's paper, and there's scissors, right? Okay, so we've got this choice. And then one thing I would probably like to do is, since each of these has a point value associated with it, 1, 2, and 3, I want to go ahead and assign that point value to the enum. Don't look at part 2. Spoilers. So rock will be 1, paper will be 2, and scissors will be 3. Those are our 3 choices, along with the point values that they are assigned according to this text. The other thing that we will want to do is we will want the ability to parse our input into these choices. So I think one thing that we might do is we might just use the from string trait so that we can just use string.parse and then pass the string slices for each of those characters. That would be a very rusty thing to do. So if we do impl from string, I never remember how to do this, so I have to look it up. So if we do rust impl We can probably see one here. Yeah, so here's impl. Sorry about the text. I'll try to keep everything large enough so that everyone can read it. And so yeah, I'm just going to impl from string for choice. And then usually denote an error here. So type error. They're using a parse int error. I don't know what I'm going to do. I think I'm just going to ignore that for now. So we define a from string function, and we take some string, and we're supposed to return a result, which is self. I see why I do that, so it's nice and clean. Which returns a result that is either a choice or a choice error. And so in my case, I'm just going to say that this is just the default error struct. I'll also maximize this here. Okay, so cannot find from str in this scope. It's not found. It is because I need to import it, so I'll just go ahead and do that. So I'll do use std string from string. Now that should complain less. Trait objects without an explicit dynamic are deprecated. It's a hard error in Rust 2021. What do you know? All right. I will admit I'm not exactly sure what that means. So for now, I'm just going to do, instead of having a type alias, this is an enum variant, std result error. What? It has its own error? Am I crazy? I think I'm crazy. Alright, we're already stuck on rusty things. That's fun. Not all trait items implemented missing error. Oh, okay. So the trait requires that you have an error type defined. That's interesting. I like that actually. So I will put that type alias back. So error, and I think this is actually supposed to be error. That's my main problem, not ERR. ERR is what the internal error type for this trait is supposed to be. So we'll put this back to self error. It still does not like that. Do I need to use it? I don't know why that would. I don't know why that would help. I'm wondering if it's because this isn't. This is a trait. But my understanding is that should be super chill. I wonder if it's because this error needs to implement certain traits itself. Like you can see here, debug and display. It might need to implement both of those. But I'm pretty sure the error out of the box, yeah, it's the same thing. Anyway, let's see what's actually saying. Traits without an explicit dynamic are deprecated. Okay. The size of the values, dynamic error cannot be known at compilation time. All right, well, we'll come back to that. For now, what I want to do is, so given a string here, what I want to do, right, is if I've got A, I want that to become rock. If I've got B, I want that to be paper. If I've got C, I want that to be scissors. And same for X, Y, and Z. So what we should be able to do is we can look at the characters. So if we look at the first character here, and this will be an optional character. So what we can do is we can match on this, bada bing, and what we should be able to do here is say A, that's going to be choice rock, right? And this will need to be some because this is an optional. So we'll say if we've got sum A, right, because we could get empty string. So we've got sum A, we've got choice rock, and that's going to be okay for our result. So there we go. We just need a few more of these. So we've got A, B, and C, and that's going to be rock, paper, scissors. Alrighty. Yep. And we're going to do the same for X, Y, Z. And I can't remember for sure if Rust has a way to have multiple matches, because we could do sum A or sum X. Yeah, so you can use this this little pipey guy. So we could do sum X or sum A, sum Y or sum B, and then sum Z or sum C. Cool. So that should parse everything correctly as we understand it. The other thing I know that we're gonna need is like we're gonna need to be able to compare these to see, you know, like who wins. And so I think that's one of the next things we'll do. But I would like to figure out this guy. I don't know. Does it just want this to be dynamic? But I don't think that will work here. Yeah. So if I come back here, yeah, required associated types, the associated error which can be returned from parsing. Very weird. Yeah. I think I could just put this in a box. That seems pretty silly. Yeah, it still doesn't like that. I don't know. I don't know what I'm doing wrong here. Let me go see parse error. Parse. There's probably a couple in here. Cool. std string parse error. Alias exists for backward. Okay, so we don't want to use that. Parse char error. That's probably pretty close. Let's take a look. From error which can be returned when parsing a character. This struct is created when using the char from string method. Okay. I mean, I guess ultimately I'd like to have my own error if we're trying to be, you know, as rusty as possible. And I think this error is supposed to, let's just look it up. Define custom error type. Defining an error type. Beautiful. Here's this double error. They set up a struct, and then you implement display for it. So relatively simple. Let's do it. And so this will be struct error. And we'll derive, debug, and clone. Although I think we just need debug and display. Struct is not supported in traits or impls. Consider moving the struct out to nearby module scope. What? Okay, so this will be parse choice error type error equals maybe, well, what is this supposed to have? I'm not sure. So this will be parse choice error. cannot find parse choice error in this scope. Struct is not supported. Okay. And then I need the display macro. So std format display, I believe. No? I guess you can't derive display? I swear I've derived display before. Alright, well. Guess not. So let's impl std format display for parse choice error. And the formatter function takes reference to self and a mutable reference to a formatter, returns a format result. Cool. And then we can write to the formatter self. Cool. Okay, and just like that, things seem to have gone away. I'm going to see if I can hoist this up into here. Error. Oh, it does not like that. It really wants to be out of there. It's weird. Very weird. I don't know exactly why that is. Okay, so the next thing we need to do is have like a default for this match arm. And so for this, of course, we're going to have our parse choice error. So this will be error parse choice error, just like that. So now we have a way to parse these, parse our input. We should be able to get started on that. So let's take our input, bust it up into lines, and we want to map each line into a tuple of choices, right? So we've got a rock and we've got two choices. We've got a rock, paper, and scissors and a rock, paper, and scissors. And from that, we will then need to calculate some score, right? Excuse me. So if we take our input lines, what we want to do is map over those such that we end up with a pair of choices. So given our line, we should be able to, if we take S at 0, and I can't remember if that's going to return a string slice or a character. Yeah, it's not. So what we need to do is figure out how to get slices. So rust slice string, because I do not remember how. As bytes. I don't really want bytes. I just want the first character of a string. So maybe what I should have done is had this take a character. Would probably have been the smarter thing. But I kind of wanted it to just take a string and be simple and flexible. But yeah, this is what I'm looking for. That's what I'm looking for. So in my case, I should just be able to do 0.1, right? So 0.1. And this can do, we can, what am I doing here? This needs to map to a tuple of choices. So choice. And so this will be dot parse, and we also want 1 dot parse, and these are going to be technically that like it could be a parse choice error. It's a result type, right? So I'm going to go ahead and unwrap, which is not very rusty. Don't do that, but we'll see how that goes. Okay, so real quick, one thing I want to do is just change this part 2 test so it fails, so it doesn't look like anything is working. That will be helpful for me. All right, and we've got some syntax errors, and I think I will, for now, just throw that on the bottom while we get to work here. Yes. Mismatched closing delimiter. This should call map here. That is, it's not very pretty. We'll say that for free. This function takes 2 generic arguments, but 1 generic argument was supplied. Map has 2 generics? It takes a function f. That one should kind of be implied, I guess, but maybe not. And that f returns b. Yeah, that makes sense to me. I should be able to infer that. But I guess maybe if you provide 1 generic, it does not try to do any inference. So we'll drop that. Expected one of closing parentheses. Oh, yeah, cool. So parse here is going to want the annotation choice. And they call that the fat shark or something, I believe. Unused map must be used. Cool. So now we're mapping this to our tuple of choices. And real quick, I just want to see what this looks like. So I'm going to say let choices and then just dump that. Print line. And we will just show the debug output for our choices. At least, yeah. So here we go. Here's our map, which maps are not fun to look at. So let's collect this into like some sort of array or vector. Yes. So if I say that I want a vec of choice tuples, so choice, I think that would be closer to what we want. Choice cannot be formatted because it doesn't implement debug. I thought you could dump vectors. Still? No? Okay. Rust, print line, vector. Yeah, this seems to indicate that that you can. Am I crazy? What is choices? That's a vector. Oh, it's because I've got a tuple in there, I bet. Yeah, choice doesn't implement display. Huh. Rust. Oh, you know what? I think I just need to derive display and debug for choice. I guess you can't derive display, so I don't know what that entails. But yeah, so if we make sure that choice can be debug outputted, this seems to do stuff. Panicked at begin. Okay, yeah, so we're getting string slicey slice length issues. So I've probably done something wrong here. Yeah, panicked at unwrap on an error value. Yep, so when we're trying to parse our stuff, we're parsing the wrong stuff. So one thing I will go ahead and do is I will, just for sanity here, I wish I had set up a debugger for this, but we'll look at what exactly our slices are given back. Yeah, it's already upset about this. Doesn't have a size known at compile time. Yes, that's true. That is correct. Is that part of the problem? Okay, there we go. We need to just pass a reference. So there we see A. That's correct. We should be able to parse frickin' A. And so this one I would expect would be our space. And so just to make sure that we can see it, that one is nothing. There is nothing in there. Very weird. So I'm wondering if I'm using that wrong. Yes, okay, so that's why. This is index to index, not index to length, which makes perfect sense if you would just look at it and, you know, read it properly. So now if we change this, we should see now our vector of choice tuples. So we see rock, paper, paper, rock, scissors, scissors. And looking at the advent of code problem, which we have lost. So looking at this, you know, we see rock, and then Y is paper, B is paper, X is rock, C is scissors, Z is scissors. Yeah, so that we're parsing these correctly now. That's awesome. So let's go ahead and just clean up a little bit for the sake of sanity. Yeah, that looks good. That's looking good. Okay, so we're now successfully parsing these choices. Some of this stuff is a little ugly. One thing we might want to do is figure out how to get rid of these unwraps later. But let's see if we can get to a working solution before I run out of time here. Okay, yeah, so our test, we should end up with 15. So now that we've got our list of choices, right? We've got our actual rounds, our games being played. We should be able to take that and convert that to points. So one of the things we want to be able to do is compare choices. So Rust has a trait for comparison. So the CMP module, it has utilities for comparing and ordering values. Since like ordering is not something we're going to be doing, right? These don't have a distinct order, like rock beats scissors but doesn't beat paper. So this isn't going to be ordered in terms of like numbers, but we should be able to say like greater than or less than or equal to. And so we should be able to do some sort of I think equality is the wrong word because that's just equal or not equal. There's not like a greater than or less than. I'm not sure how ordering works. Yeah. So ordering is less, equal, or greater. So for this, we should be able to set up a who wins, who loses via comparison, which is great. So I think the thing that we need to do is we need to implement this. So this is the enum, right? This is less or equal than or greater than. What we want is to implement. We want to implement ordering for our enum, whatever it's supposed to be. And so I'm not sure what the trait is. I think maybe that this is the trait, but this is the enum, right? There's variants, implementations, impl ordering. Yeah, okay. So I think we can impl ordering for choice. And there's a couple functions we have to implement, I believe. So let's pull in that trait, std comparison ordering. Now this is going to say what functions we need. Expected trait, found enum. Nope, Nope. So I've got the wrong thing. I've got the wrong guy. The trait is ord. Okay, so that's what I'm looking for. So ordering is the enum, which is less, equal, or greater. Ord is the actual trait that you implement. So if we impl ord for choice, can't compare choice with choice. The trait partial ord is not implemented for choice. Okay, so we have to implement partial ord first. Let's learn about this together. So this is a trait for times that form a total order. I don't know what that is. In mathematics, a total order or linear order is a partial order in which any two elements are comparable. That is, a total order is a binary relation is less than or equal to. Nope, this is all math stuff, so that's not less than or equal to. I don't know what I'm talking about. On some set X, which satisfies the following. And there's going to be math symbols that I don't understand. Total orders are also called simple, connex, or full orders. So just reading that, right, in which any two elements are comparable. We have that situation. So let's poke around here and see what we can figure out. That is a macro for deriving. Here's the partial ord trait. Traits for types that form a partial order. Less than, less equal to, greater than equal to. Methods trait can be called using those operators. Methods of this trait must be consistent with each other. Okay, so I think we also need to implement partial EQ. And that's how we can do all the stuff here. So partial EQ, I bet we can derive, right? If they're the same, they're the same. No problem there. So we'll pull that one in, partial EQ. But the ordering is where we get a little weird. So consider annotating choice with derive partial ord. Haha, not quite. Our ordering is going to be a little wacky. Yes, so now this is saying not all trait items. We're missing partial comp. This guy. So let's see exactly what this is supposed to be able to do. How can I implement? Only requires implementation of the partial comp method with the others generated from default implementations. So looking at this, I don't know what this is supposed to do. This takes a thing and another of that thing, and it returns an option ordering. Okay. I'm thinking we don't want partial ord. We want ord. So if I just do ord, is that going to be happy? Consider annotating choice with partial ord. So maybe I don't want partial EQ, and I can just do EQ, partial EQ, and EQ, choice. Yeah, it really wants partial ord. Okay, so let's figure out how this goes then. So we've got this function, partial comparison. It takes a self and another self, so other, which is also a reference to one of these selves. And this returns an option ordering. Okay, so this has some provided methods. Goodness. And I think if we just implement greater than, the rest of it, like that would be the only thing we need, right? Because greater than implies which one is less than. So in my case, I'm going to, I don't know if I can do this. These are provided methods. Greater than for self and other, and is used by the greater operator, right hand side. So method tests greater than or equal to. Yes, but I need my own. That's why I'm not sure about partial ord. I'm not sure about this. Consider annotating choice with derived partial ORed. But why? I think I just need ORed. I don't know what I'm doing, I admit, but ordering, and then this becomes not as optional. Yeah. So can't compare choice with choice. The trait partial ORed is not implemented for choice. I've never tinkered around with these traits, but I'm excited to. So this, yeah, you need a function comp, which definitely must return in ordering, it looks like. The implementations must be consistent with the partial ORed implementation. So does, oh yeah, look at that. Okay, so this trait ORed requires that EQ and partial ORed be implemented for the type. Okay, cool. That's what that means. That makes perfect sense. Okay, so we definitely need partial ORed. I don't know how that fits into this. I don't know. So let's go check out partial ORed. So here, partial ORed requires partial EQ. So that makes sense to me. Where right hand side is sum sized, and then partial comp. So let's go see. Let's go see. Let's go read. Let's read together. So here, they're calling partial ORed for person, and they're just using comp. Okay, so that sounds like exactly what we want to do, and then they're comparing the height in this example, and then partial EQ. Okay, so it looks like your partial ORed implementation can use your ORed implementation. Your ORed depends on partial ORed, so it's kind of backwards in my brain, but also I'm a total scrub at this. So that makes sense. So let's have our partial comparison, other and self, option, ordering, right? And then this is just going to do self comp with other, and we have to wrap this in sum since this returns an option. Okay, beautiful. Okay, now I'm tracking. I'm tracking on how this makes sense. So this we need to return in ordering, right? Okay, so this is where we put all of our rock, paper, scissors logic, right? So if the first thing is if we've gotten an equality, right? Ordering can be equal. So if self equals other, then we can return equal, right? Why am I struggling with this? Ordering equal. Done. Else, if we are rock, so else if self equals choice rock. So if we're rock and if other is equal to choice paper, then we lose, right? So ordering less, and then else if other equals scissors, and I can quickly see that this is going to be a little bit ugly. Then we are greater, right? So if maybe missing an else clause. So in this case, I'm just going to say else because we're handling the equal case here. And then if we're rocking their paper, then in any other case, we're going to be greater, right? Okay. So I'm just going to switch this up a little bit so it's a little more clear. if maybe missing an else clause. Yes. So else if, I'll just leave a comment here. We've already checked equality. So the only other possible code path here is scissors. This would not be true if we like add something, right? So if we add like lizard and Spock, I don't know how that works. But if we added lizard and Spock, Rock would suddenly beat lizard and Spock out of the box with this logic. So I'm wondering, there's probably a better way to encapsulate this that handles all the cases. But I'm not really sure what else that would look like. I guess you would want to use a match, and you would want to just handle every case explicitly. And that's what I did in my other code. It's not ideal, but I'm thinking that that's probably the most rusty and correct way. So I think I'm going to go that route for now. So if we match self, and we have choice rock, then we're going to match other. And so if we've got choice rock, we've got ordering equal, right? We've got scissors, rock beats scissors, so we're greater. If we've got paper, paper beats us, so we're less, right? And that's how this works. And so now, anytime if we were to add choices, right, then we would come here and we would expand our comparison function so that we cover every case. And this match won't let us leave out any cases, which is nice. So it gets kind of ugly, for sure. It is for sure kind of ugly. But it babysits us, which I kind of like that. So paper is greater than rock, paper is less than scissors, and paper is equal to paper. You can kind of see how this goes. Scissors is less than rock, is equal to scissors. Why have I ordered this weird? Rock, paper, scissors. Rock, paper, scissors. Rock, paper, scissors. And we are greater than paper. Excellent. Okay, no more warnings. It's very happy. We can now compare rock, paper, scissors. So we should easily be able to tell who wins by just using greater than or less than operators, which should be really nice. Okay, so we can parse choices because we've implemented the from string trait for our choice enum, and we can compare choices because we've implemented the ordering trait for our enum. So now all that's left really to do is write out the scoring logic, right? So I think that the simplest way to do this is we can write a function that takes two choices and calculates a score, right? So function score will take two choices, right? So there's opponent, they have a choice, and then our choice. Us? I don't know. Opponent and mine. I don't know. Naming things, one of the great problems. And this will return a score, which we'll just use I32. Okay, so the score is calculated based on, if you'll remember, it's this number plus whether or not we won. And that whether or not we won is, 0 is a loss, 0 for a loss, 3 for a draw, which is equality, and then 6 for a win. And so if you kind of, so it's like 3 times the outcome of the comparison. And so I'm curious if, like, if we go and look at the ordering enum, this is represented as an I8. So we can see, I'm wondering if we could just cast that and multiply, like as less 0. I think that's what is implied. But I'm not sure, and I'm not exactly sure how to check. Oh well, I'm not too concerned about it. I'd rather type it out anyway, but if we wanted to get really fancy, we could do that. So our score is going to be the value of mine plus whether or not we win. So we want to match on our choice comparison. So match on whether or not mine compared to my opponent. So if we get ordering less, we're getting 0 points for that. If we get ordering equal, we're getting 3 points for that. And if we get ordering greater, we get 6 points for that, right? So what is it complaining about? Cannot add integer to choice. So what I need to do is I need a way to cast my enum to an integer. So Rust enum to integer. And let's figure out how to do it. It looks like you just do as your thing. So mine as I32. Piece of cake, and then that was a typo. So mine.comp wants a reference to it, so we'll just pass the reference. Okay, so this should return the score for some choices. So now what we should be able to do is, instead of mapping this to a tuple of choices, we could just calculate the score for those choices, right? So if I do score and we pass the first one and the second one, right? So the opponent's first and then mine, then we're going to end up with a bunch of these. Now, since we are like summing up a bunch of numbers, instead of doing a map, I'm just going to go ahead and calculate this as we go. So I'm going to change this to fold. And there's the information for fold. It takes an initial value and a function. So I'm just going to start at 0 points, right? Because that's how much we're going to end up with. The function for fold takes B and the item. So B is that initial value type. So this is going to be points and then our line. So line. And I'll change those to line. And I'm just going to take points plus the score, and that should be our get rid of all this crap. So we're taking the input, we're converting, we're looking over each line, and then we're folding, which is like reduce. You've probably seen reduce before. So we're going to start with 0, and we're going to take that 0, whichever those points are, and each line, and we're going to add the score that we get from those two choices, our opponent's choice and then our choice, to our points, and we'll return that, right? And it's very much like a reduce. And you can see we are passing part 1. That is awesome. So what I'm going to do now is I just want to make sure that we end up with the correct answer for our real one. And so I'll write that, and you can see for part 1, I'm getting 12535. And that code is just up here, right? So we are taking our input for the day that we have fetched previously, and calculating the part 1 value for that, and then dumping that to standard out. So let's go see if that's the correct answer. So advent of code, go here. Yep, so my puzzle answer was 12535. So that's the correct answer. So we're done with part 1, which is fantastic. I'm going to save this code. Part 1 done. Coolio. Okay, so the next thing to do is part 2. So we scroll down to part 2, and we're going to get some disappointing news for this solution. The elf finishes helping with the tent and sneaks back over to you. Anyway, the second column says how the round needs to end. X means you need to lose, Y means you need to end the round in a draw, and Z means you need to win. Good luck. So this sucks because we have encoded X, Y, and Z as our choices, right? So for part 2, it's going to be quite different. The total score is still calculated in the same way, but now you need to figure out what shape to choose, what choice to choose, so the round ends as indicated. The example above now goes like this. So in the first round, your opponent will choose rock, which is A. You need the round to end in a draw, which is what Y indicates. So you also choose rock. This gives you a score of 1 plus 3. Okay, so basically, what this does let us know is that we know that, let's see, the second column, Y, this tells us the ordering. And so what we need is we need a function that tells us I'm going to rename this function for score part 1. Actually, let me just finish reading the description. I'm all over the place. So in the first round, your opponent will choose rock, and you need to end the round in a draw, which is what Y indicates. So you also choose rock, and that gives you a score of 1 plus 3. 3 for the draw, 1 for choosing rock. In the second round, your opponent will choose paper, B, and you will choose rock, so you lose, which is indicated by X. That gives us a score of 1. 0 for losing, 1 for choosing rock again. In the third round, you will defeat your opponent's scissors with rock for a score of 1 for choosing rock and 6 for winning, which is 7. Now that you are correctly decrypting the Ultra Top Secret Strategy Guide, you'll get a total score of 12. So I'm going to come down here. I'm going to update my test for part 2 and make sure that that brings back 12. Okay, we cannot find function score because I renamed it because we're scoring part 1 differently from the way that we are going to be scoring part 2. Score part 1. Okay, so now we are failing our part 2 test, but we should be able to get something going. Okay, so this is how scoring is calculated in part 2. Scoring for part 1 is going to be a little bit different because, this is how we're calculating scoring for part 1. Scoring for part 2 is going to be a little bit different because what we're given for mine here is actually the ordering, right? And so we can reuse score part 1 because this still calculates the score correctly, right? This takes mine, rock, whether we chose rock, paper, or scissors, and then checks whether or not you won and gives you the correct points. So for part 2, the only thing we really need to do is look at the opponent's choice and look at the if it's X, Y, or Z, right? The character. If it's X, Y, or Z, then we need to figure out which one to pick. And then we would pass that to score part 1, right? That's how we would do this if we were going to reuse our previous code as much as possible, I think. Okay, so score for part 2. For part 1, yeah, it's going to look pretty similar. Instead of doing score part 1, we're going to do score part 2. And again, we're not going to be passing the choice. We're going to be passing, X, Y, or Z. And really, that is the ordering that we are going for. That's yeah. So, let me see. I guess if we wanted to be cool again, we would set up a parse for the ordering. So I'm going to take parse choice error. I'll put this stuff down here for part 2 to indicate that it's kind of part 2 specific. I'm going to do a parse ordering error. And then we want to implement from string for ordering. You probably shouldn't do this. Just saying. So this is implement from string for ordering. This is going to be parse ordering error. And so here we are going to take these guys and we want, yes. Okay. Okay, yeah, so we can't implement traits for types defined outside of our crate. So that makes sense. That makes good sense. So what we want then is we want a function that given some character, we would want to know what ordering we want. So desired outcome, and this will take a string, and that is going to return an ordering, right? So yeah, this should be a result. Good call. Result, which is an ordering or a parse ordering error. Mismatched types, found unit type. Oh yeah, okay. So these choices need to be ordering, right? So if we get X, that is lose. So ordering less. If we get Y, ordering equal is what we want. And if we get Z, we want ordering greater. And then otherwise we're going to get our parse ordering error. Yep. So this needs to be parse ordering error. Okay, so now this parses X, Y, or Z to our desired outcome, which we need for part 2. The other thing we need, though, is given the opponent's choice and the desired outcome, we need to know what our choice is so that we get points for that. So if we know that the opponent is choosing rock, and we need to end it in a draw, we know that we also need to choose rock, right? And then we can calculate our points. So what we need then is we need a function that given the opponent's choice, right, and what outcome we want, we need to know our choice. So I'm going to say desired outcome. I'm going to say outcome. I'm going to make a function called outcome choice that takes the opponent's choice and our desired outcome. So outcome ordering. So desired outcome. And so if this is going to be another big ugly match statement, right? Because there's no, like, we could permute each choice and just find the first one that produces the desired ordering. But I think I like having the completeness. I think it's the most rusty to have the exhaustive pattern match. So I think I'm just going to go with that, right? I know it's going to be kind of ugly and our code is really long, but the goal of this is learning Rust. The goal of this is not, write the best, shortest advent of code solution. Okay, so given our outcome choice function, if we match on what the opponent played and our desired outcome, so desired outcome, I'm going to do the same thing here, desired outcome, and then these are going to be flipped, right? We just need to flip these. And so I'm sure there's a cool way to do this in my text editor of choice. So we'll try to get fancy here. Paste. Jump to the end. And delete all those. Put commas. Cool. Piece of cake. So here, snag these. Paste them. Bada bing. Take those, paste. Oh no. Paste. Okay. So now we flipped that. So if the opponent has chosen scissors, and we need to lose, these are backwards. Gosh dang it. Okay, so if the opponent chooses rock, and our desired outcome is a draw, which is equal, then we choose rock. If the opponent has chosen rock, yeah, so these just need to be flipped. So this is greater, this is less, right? Because instead of trying to figure out what wins, we are figuring out, yeah, it's backwards. You get it. So paper, if we need to win, we choose rock. And sorry, if we need to lose, we choose rock. If we need to win, we choose scissors. So if they throw scissors and we need to lose, if we choose rock, then we are needing to win. If we choose paper, we're needing to lose. There we go. Okay. Match opponent. Expected. Oh, yeah, we don't have a return type. So this is going to return the choice that we should pick. Okay, so finally, after all that, I think we're ready to wrap up part 2 and be done with this. So part 2, to calculate the score for part 2, right, we have to first parse our desired outcome. So let desired outcome equals desired outcome of mine, and I'll just change this to outcome, and then our outcome choice is based on the opponent choice and desired outcome, and so given this, we can then use the same score part 1 where we are going to pass the opponent and our outcome choice, given the opponent's choice and the desired outcome. Ta-da! Arguments to this function are incorrect. Desired outcome, oh, is a result, right? So we need to just unwrap this. This otherwise works exactly the same. And instead of that, because we need to pass the, the outcome string. So that's going to be 2 to 3. Line 2 to 3, and slice it. Very good. Okay, so use a move value opponent. Okay, so good. This highlights something that we probably want to do, where most of our functions that take choices probably just need to take references to choices. And so, yeah, I'm going to do that. So can just start turning all of these into references, which totally fine. It's better that way anyway, right? It really is. So bada bing, get rid of that. Have to dereference that guy to cast it to an int. This is going to be a reference, reference. Function defined there. Score part 1. Arguments to this are incorrect. Oh yeah, because we need this to be a reference as well. Okay, so looking at it, we are now passing part 2, and we can see there's our part 2 answer, 15457, and that is my answer. So that's it. That's our Rust solution. Pretty fun. We learned a lot of really cool Rusty things. I'll commit this. Part 2 done. It took us way too long, but that's not really the goal of this style of Advent of Code. The goal of this presentation was really to kind of show off traits and how implementing them works, making use of the standard library, using ordering for rock, paper, scissors, debatable, kind of sketchy to be honest, but it was fun to do it. The other cool thing we learned, how ordering and equality works in Rust. That was really cool. And other than that, we kind of got stuck on some weird error stuff, which I did not fully understand. So I will have to learn some more about that. But other than that, I'm pretty happy with this solution. One thing I would like is this is like very related to this. So I'm wondering if there's like a way to kind of derive both of those large match blocks from one another and kind of reduce the code repetition here. I think that would be the main thing that I would want to clean up out of this is somehow we should be able to base those off of each other. Other than that, I'm very happy with this solution. Much happier than my first one. So I really like that we were able to use an enumerable, and we wrote how to parse the input to get our enumerable. I really liked how we were able to do that. It came out very clean. The other thing I would want to do is ditch all these unwraps. So properly handle errors. That'd be something I would want to do if this was serious Rust code. So in my experience, anytime you have .unwrap or you're ignoring option or result types completely, you've probably got a problem and you want to not be doing that. So I would want to clean up all these unwraps. Yeah, pretty stoked. That worked out really well. So thanks everyone for tuning in. I'll get the recording slapped up to YouTube somewhere or something as soon as I can. But yeah, that was fun. Thanks for coming. I'll see you guys later.